So this is an atomizer explosive trace detection system. It uses a technology called ion trap mobility spectrometry. And pretty much all of the explosive trace detection systems that are deployed by the airports are going to be using an IMS, ion mobility spectrometry type technology. Now there's different ways they do that. We're going to go over that and explain how all of that works. But we're also, at this portion of the training, we're going to explain to you how the system basically functions and how it's actually doing its explosive detection based on all of the different parts and pieces, but how it all actually works, all right? So if you're using a system like this, you're already familiar that you're going to have some sort of sample trap that you're going to collect the sample with. These are typically made out of a Teflon, and actually on this portion where you collect the sample, they'll rough it up so it actually has more ability to capture or collect particles as you run it across the surface. So that's what it's specifically designed for. Some of the systems will have you use a wand. A lot of places they'll just use their finger, and you'll do it by hand, by what we call hand sampling. And then you'll take and place the sample inside the system into what we call the desorber. Now the desorber is basically a toaster. It's a heater, and it's heated up to a specific temperature based on what you're actually trying to do. So if you're looking for narcotics, you're going to run at a much higher temperature than you are going to run if you're looking for explosives, because narcotics are a lot harder to turn into a vapor, so they have to operate at a much higher temperature. So when you start looking at a chemical of, whether it's a drug or if it's explosive, you have to look at its melting point and boiling point to get an idea of what temperatures you have to be at to get it to desorb whatever particles you collected on here to get turned into a gas and then sucked into the system through the desorber. Now the desorber, again, is on this system. It's located right here. It's right underneath here, and it is literally a toaster, all right? And this one right now is probably, I believe, heated up to around 220 degrees Celsius, which is the optimum temperature for detecting explosives. Now, if I switch this over to narcotics, it's going to raise the temperature of the desorber to a higher level. And that becomes an issue, especially if you're trying to do narcotics and drugs at the same time, because when you do that, when you raise that temperature, you start burning off the faster traveling explosives that show up at the first part of the plasmagram. That's your PETNs, your nitros will start actually burning off before they can ever be sampled into the system. So you can't run a system on what we call dual mode. There's 3 modes on here that you can run the system, and I'm not talking about what you're seeing here. This is the plasmagram. You've got the negative mode on top, which is the negative plasmagram, so negative ions, and down at the bottom you have the positive plasmagram, which is showing you positive ions. This system always scans in a positive and negative mode, so it's a dual mode detection system. Now where the confusion comes in is in the programming. When I switch it over to drugs or narcotics, those are different modes. You've got explosive mode and you've got narcotics mode. And all the systems also have what you call the dual mode. And this is where people get confused because they're thinking dual mode is the same thing as this. No, it's not. And I've known people that have set their system to dual mode when they're only trying to detect explosives, all right? What happens in dual mode is you're trying to do narcotics and drugs narcotics and explosives at the same time, and what's going to happen is you're going to raise that temperature up and start losing sensitivity for your explosives because you're burning a lot of them off, and you're going to burn off those faster traveling explosives in your plasmagram like your nitros and your PETNs. All right? So if you ask me how I know all this, I have been working with explosive trace detection system before there was a TSA. Okay, before Department of Homeland Security, before any of us, the State Department had one of the most extensive explosive trace detection programs in the world. We deployed these all over the world to every embassy consulate that we had, and I was the one that tested and evaluated all the different technology, and I used live explosives. We built IEDs, we tested them, we did all this stuff, and we really fully vetted this technology in regards to what it can and cannot do. And then, after 9/11, we watched TSA stumble through trying to deploy these systems at the airports, and initially it started like the Atomizer 2s. We were already on the Atomizer 3s at that point, Atomizer 4s, and getting into gas chromatograph systems. So I know these systems intimately. I even know how to repair them, take them completely apart, and put them back together again. So in a later video, we're going to show you internally how this entire process works of how it actually takes a sample and what's happening technically on the inside of the system. So when we talk about dual mode, what we're talking about when you're talking about detection is the system can look at positive and negative ions at the same time. All right, that's what it can do. There might be programming software in here or menu options that let you switch to a dual mode, but it's always operating under a dual mode as far as looking for positive and negative ions. And on those modes, you need to be in the mode that optimizes the temperatures, especially in the desorber, and also it changes the temperature in the drift tube if you go to a narcotics detection or a dual mode detection. So if you're looking for explosives, you have to be in the explosive mode because the temperatures have been optimized for explosives, okay? I don't care what system it is, that desorber temp needs to be around 200 to 220. There's been testing and evaluation done. I think in the training you're going to see a paper I reference where they figured out what the optimum desorber temp was for detecting explosives to get the strongest peak height. Okay, so as you go up in temp or go down in temp, you lose detection capability on either the positive and the negative mode depending on where you're looking for those explosives at. All right, so that's the first part of explaining this technology, and one of the biggest things people get confused about is the dual mode and how important the temperatures are on what program you're running to make sure this system's going to work for you the way you want it to work.